In this video, we're going to discuss the average value of a function. So, over a specific interval, so looking at this graph from A to B, what we're looking for is what is the average y value of the graph over that span. So, we have some graph that can do a lot of different things, but we can find the average y value over a span of, over a domain of our x values here from A to B by using this formula. So it's simply you just do the integral from A to B of the function, and then you multiply by 1 over b minus a. So you're essentially dividing by the length of that interval is what that amounts to. Okay, so I'm going to set this up. We're going to find the average value of the function 1 plus x squared on the interval from -1 to 2. So our setup here would be we would do 1 over 2 minus -1 times the integral from -1 to 2 of our function 1 plus x squared dx. And then we're simply just going to evaluate this. So out front, that would turn into 1/3. So I'd have 1/3 times the integral from -1 to 2 of 1 plus x squared dx. And then to evaluate this, keep that 1/3 out front, and then we're just going to do the antiderivative. So antiderivative of 1 would be x, and of x squared would be 1/3 x cubed, and we're going to evaluate that from -1 to 2. I'm just going to keep this 1/3 out front. If I plug in 2, I'm going to get 2 plus 1/3 of 2 cubed. Well, 2 cubed would be 8. A third of that would be 8/3. Minus, if we plug in -1, we're going to get -1. And then -1 into 1/3 u cubed is going to be -1/3. So that's going to give us 1/3 of 2. I'm going to save this for a minute. So minus -1 is going to be plus 1. And then what we have here is 8/3 minus -1/3. So plus 1/3. 8/3 plus 1/3 is 9/3, which is 3. So that's 1/3 of 6, which is 2. So what we found is that the average y value of the function 1 plus x squared on the interval from -1 to 2 is 2. So I have this graphed over that specific interval, 1 plus x squared. And if we were to track all these y values over the span from -1 to 2, the average y value is 2. Now we can then go on to figure out where that happens in this interval. So that's not part of this question, but it could be. Our interval is -1 to 2. If I wanted to know what x values actually give me that average value, all I need to do is set my function equal to the average value, and I can figure that out. So if I set my function 1 plus x squared equal to my average value, which is 2, and I solve this, I'm going to get x squared equals 1, which means x could be positive or -1, both of which are in that interval from -1 to 2. That value is where those happen. So if you look, I'll just label both of those points. At -1, we get a y value of 2, and at +1, we get a y value of 2. Those are the x coordinates. The x coordinates where that average value happens at 2. Okay. The mean value theorem for integrals kind of expands on this idea a little bit. And it essentially says that if you have some function, so we've got some function f of x, that's this graph here. If I wanted to find the area under this curve, so let's say I wanted to find the area under f of x above the x-axis. If I can find the average value, so that's this y coordinate, whatever that happens to be, that's my average value. Essentially what we're doing here is we're making a rectangle where the width of the rectangle is the width of my interval from a to b. So that's this part right here. b minus a is simply the width of that interval. And then if I can find my c value, which is what we just did up here, finding the 1 and negative 1, if I can find that c value where the average value happens, which would be f of c, that's going to be the height of my rectangle. And so I've got this width, b minus a, this height, which is f of c. C is that place where the average value happens. Then what we end up with is the area of a rectangle here. If I multiply those two values, the width times the height, I have a rectangle that has the exact same area as the area under the curve. Okay? So the calculation there is a little bit easier, and it's basically saying that the area under the curve from a to b is simply just equal to the area of this rectangle that we were able to make using the average value and the width of the interval. And so I'll show you what that looks like in Desmos as well. So we have this graph only over the interval from negative 1 to 2. This is 1 plus x squared over that interval. We want to find the area under that curve, so the integral of that would actually be, the answer to that is actually 6. Okay. But if I want to estimate that, or if I want to find that exact value using average value, well, we found that the average value was 2. We also determined that the average value happens at an x-coordinate of negative 1 and also at 1. So if I were to just draw a rectangle from negative 1 to 2 that had a height of 2, that is my average value, this rectangle would have the exact same area as the area underneath that curve from negative 1 to 2, both of those values being 6. Okay, so that's what we're finding when we're using that mean value theorem for integrals. We're finding that rectangle that would give us the exact same area as the area under the curve.